All right, so I'm going to be going over the last set of questions on homework 9A. So we're just going to hit all the ones that we haven't covered so far, and most of these ones are going to deal with parabolas and finding the vertex or the domain or max and min. So they're all kind of dealing with the same kind of things. So the first one is my question number 1, which says let q of x equal negative 4x squared minus 10x minus 6. And it says the extremum value of q of x is attained at x equals and y equals. And it asks, is this point a local maximum or minimum? So the first thing to remember with parabolas is that we know this is a parabola because it is an x squared polynomial. So that is the degree. It's a squared function, so that means that it's a parabola. And then when we think back to transformations, we know that a general parabola is facing up, and we call this concave up. It's positive. And if we have a negative, then it's called concave down, and it faces down like this. So this parabola will be facing down, and so actually it will have a high point, which is up here. So a downward facing parabola will actually have a maximum value. If we have an upwards facing parabola, it will actually have a minimum value. So that's what we are looking for. And this problem is actually, it wants us to find this point, x comma y. So in order to find the vertex of a parabola, you have to memorize, the easiest way to do it is to memorize this equation for the vertex of a parabola, and it's negative b over 2a. And this is actually derived from the completing the square formula. And so you can actually complete the square to figure this out, but this is probably the easiest way to go about finding the vertex, is just to use this. So we know A, B, and C, the leading term is the A term, this is the B, and this is the C. So if I'm looking for negative b over 2a, I'm going to take negative 10 over 2 times a, which is negative 4. And then I just simplify this. So negative 10 gives me a positive 10, and then I have a negative 8 on bottom. So I get negative 10 over 8, which simplifies to negative 5 over 4. So this just gives me my x value of my vertex. So in order to find the y value, I actually need to plug this in to q of x and solve for y. So y, or q of x, is going to equal negative 4 times negative 5 over 4 squared minus 10 times negative 5 over 4 minus 6. So then it's just a matter of simplifying. I have negative 4, I need to square this first. Negative 5 squared is 25. 4 squared is 16 minus, actually I can simplify this one. Negative 10 times negative 5 will give me a positive 50 over 4, and then minus 6. When I multiply negative 4 times 25, I get negative 100 over 16 plus 50 over 4 minus 6. So I just want to simplify that. I'll go ahead and plug it into my calculator at this point. Negative 100 over 16 plus 50 over 4 minus 6 gives me 0.25, which is 1/4. So that's my y value. So I plug these in, and I get negative 5 over 4 and 1/4. So I just want to plug that in, make sure it's correct. And it is all good. So the next one I'm going to look at is number 7 on my common version. And it says, a ball is thrown straight upward at an initial speed of 84 feet per second. From physics, it's known that after t seconds, the ball reaches a height, h feet, given by the function h of t equals negative 16t squared plus 84t. The ball reaches a height of 82.5 feet after T1 equals blank seconds, T2 equals blank seconds. And it's saying that T1 needs to be less than T2. So what we're going to do here is it's telling us that we have a height of 82.5 feet. So what we're going to do is plug in that number for height in our function, which would be this h of t. And then I'm going to solve for t. And because this is a quadratic, I'm going to end up with two answers. That's why there's a t1 and a t2 value. So if I plug in 82.5 for h of t, then I have 82.5 equals negative 16t squared plus 84t. And so what we want to do is solve for t here. So I might try and first factor this down if I can, or trying to see if I can simplify this at all. So 84 divided by 8. So I can, well, first of all, I want to move this 82.5 to this side to set this equal to 0. So then I get negative 16t squared plus 84t minus 82 point, whoops, I don't know I did that. 84t minus 82.5, and this equals 0. So really at this point, I think I'm just going to plug this into the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. This is what x equals. So when I plug in my numbers here, negative b, my b value is 84, so I'm going to have negative 84 plus or minus the square root. B squared would be 84 squared minus 4. A is negative 16. Oops, I'm running out of room. C. I'm going to give myself some more space here. Just move this over there. Okay. Here we go. So negative b. So negative 84 plus or minus the square root. B squared is 84 squared minus 4 times, I don't know why it's putting that dot in there. Please stop. Oh my goodness. Minus 4 times A times C all over 2 times A. Okay, so I just want to simplify this down. Under my root, I've got 84 squared. I've got a negative times a negative times a negative, so I'm going to have a negative 4 times 16 times 82.5. So on the inside of this, I get 1,776 all over 2 times negative 16 is negative 32. And at this point, because I'm doing this on the computer, I think I'm just going to go ahead and plug it in at this point instead of trying to simplify all this out. Because the 84 and 32 don't divide out. They can be simplified a little bit, but I'm just going to go and plug this in and see what happens. So I get negative 84. I'm going to try plus the square root of 1776 all over negative 32. And actually, I can simplify this. If I, these can kind of cancel with each other and get positive. Since this is just plus or minus either way, it doesn't matter. But I am going to get rid of that negative out in front. So I'm going to have 84 plus or minus the, or plus the square root of, and actually I want to be careful because I got to put the smallest one first. So I'm going to do the minus version first. So minus this over 32, and then I'm going to do 84 plus the square root of 1776 all over 32. All right, let's plug that in and give it a try. See if that works. So 84 minus square root of, divide by, make sure you're using parentheses for that entire numerator, all over 32, and then I have, I'm just going to actually copy this, paste it, and then change that minus to a plus and see what happens here. Okay, so it took my answer for 1 and 2, so there we go. You don't need to simplify that down much more, just keep it like that. Okay, so then it's asking, does the ball reach a height of 125 feet? So what we just solved for is the ball is reaching a height of 82.5 feet, and yes, it does seem to reach that point, but does it reach 125 feet? Well, we can go back and use, what we have here, it's a downward facing parabola, and that makes sense because we're throwing the ball up, and then it's going to drop back down. And so if we go back and remember how to find the vertex, back on question 1, negative b over 2a, we can find what our maximum value is. So my vertex, my max, is negative b over 2a. So if I plug in negative b, that is negative 84. All over 2 times negative 16. And if you look at this quadratic equation, we've got negative b over 2a. It's basically everything except the discriminant. So that's the way you could kind of remember that. So I've got negative 84 over negative 32, so I have 84 over 32, which is approximately 2.625. And that would be my x value, which is time, so I'm going to reach my high point at 2.625, so to find my y value I need to plug this in, so h of 2.625 equals negative 16 times 2.625 squared plus 84 times 2.625, and I'll get a value here. And I get 110.25. So that is my maximum height. So does the ball reach a height of 125? It would appear not. So I'm going to put in an n. And let me just verify that. And then it says the ball reaches a maximum height of blank feet. Well, we found that our maximum was 110.25. After how many seconds? It says round to the nearest second, so after, I don't know if it wants me to do this on this part, I'll say 2.6. And the ball hits the ground after, okay, I'm going to have to solve for when h is 0. So the answer, let me see about rounding on this one. So the ball reaches a maximum height of 110.25 feet after I'll type in 2.625 first and see if it takes that. Okay, so yes, it took all these answers as is. So no, I typed in 100.25, that it took it, and then 2.625. I typed in that whole thing, and it took it. So the last part here is the ball hits the ground. Well, a ball hits the ground at a height of 0. So we're going to plug in 0 equals negative 16t squared plus 84t. And then, see, I can factor out a negative 4t and just see where that takes me. So I get 4t plus 84 divided by negative 4 gives me, negative 21. And this is still set equals 0, so then I can just set each of these equal to 0. So negative 4t equals 0, that's going to give me t equals 0. And I have 4t minus 21 equals 0. Let's solve. and I get 5.25. So it'll hit the ball after 5.25 seconds, and it says round to the nearest second, so I guess I'll say 5. We'll see if it takes that answer. Sometimes it tells you to do one thing and doesn't like it. Correct answer. Okay, it doesn't like that. It doesn't like 5. So let's see if it'll take 5.25. You can't trust the computer. So it likes my answer 5.25. So don't round as it tells you to round. Type in the full number, 5.25, for whatever reason.